My name is Tom Kernow. I do most of the training for the company, Bardac, and I do tech support as well as application support for our customers. So what we're going to be doing is going over our P2 AC 3-in-1 drive. So this drive that you see in the picture is both in the device directory over here in Savvy. Let me just turn my. So these two drives you see here are our P2 products. These are the smallest of the drives. They're only 1 horsepower with our motors you see in our video down below. If you need to get in touch with me, just send a message to the chat window, and I'll open it up with questions at some point. Okay. Well, I'll be able to zoom into the displays and everything once we get into the software. Somebody asked about zooming in. I just wanted to get the overview right now. Okay, so I'm going to mute everybody. If you have a question, I'll just put it into your chat window and I'll be glad to answer it. Okay, so what we're going to do is with these two drives you see here, the right and the left drive over to the left screen in this device directory. What we're going to be doing is actually using a Speedy, which you can't really see here, so I'm going to go up to our website real quickly. It's one of our drive web devices that you can plug in to the drive that makes your life a lot simpler in the commissioning mode. So let me just go up to Bardac drives and I'll show you what a Speedy looks like if you haven't already seen one. And so in the products, it's the drive web world. It's our Speedy product. But what that does, you can see it in the drawing down here at the bottom. It's this little device here. I'm going to highlight it out right here that plugs into our drive that gets us on Ethernet, and also we have a port built into it for micro USB. And if you choose not to use it for actually control schemes, it can be used as a commissioning tool. So you can plug it into a drive, commission it, save your program, save a copy of your settings, and then unplug it and move to the next drive. So you can use it even if you don't use the drive web technology on every drive, you can actually use it to actually just commission the drives. And that's what we're going to be focusing on today, is using that Speedy to go in and save you some time that you could always use the front keypad, but of course that's a little more cumbersome, and you will be able to do everything with our computer here as we go through the startup. So we're going to start up these two drives in the background here. We'll start this one up together, and then maybe we'll go through it together as a group here on the other one if we have time remaining at the end of this. So we're going to go through and commission the drive in volts per hertz mode. Let me just give you a big picture here. So we're going to this drive. You see, we're going to use the drive on the left here, and we're going to commission it in volts per hertz mode initially, based on the motor nameplate, and then set it up into open loop vector and then closed loop vector, and go through the entire process of commissioning the drive. We won't really go into commissioning or actually changing the block diagram too much unless we have a lot of time towards the end. We'll just use an out-of-the-box sort of scheme, which most people use unless they're doing some more complex applications. So I'm going to put this to the side so everybody can see it. And I'm going to go in and create a couple of screens in Savvy. If you haven't already been to the Savvy training, it's available online, and we do one once a month. You can email me if you need to attend to get some backup data on how to drive the software, but I'll just sort of announce things as I'm going through them in the process here. So if you look here we're going to use the left drive here, to the left drive over to the left side of the page, and I'm going to create I've created some controls So we're actually using the terminals on the front of the drive. Even though we could talk to it via Ethernet and control the drive, I'm just using one of our DW240 platforms to control the terminals of the drive themselves, just like you would if you had a hardwired controls or maybe a PLC controlling the drive. All this is just to interface to our drive and let us actually exercise it once we go through the commissioning steps. Now let's just look at what we need to get started. If we go to let's just look at the control terminals on the drive if you're not familiar with it. Okay. So the terminals you see in the back here, this green from the green terminals you see, that's this first group of terminals that you see here from terminal 1 through 13. And there's another one you can't quite see in the video over here behind this group is some alternate contacts that are built into the drive for a Form C and a Form A contact based on how you've programmed the drive to behave. By default, one of those is a healthy and one of them is, I think the one that's a Form A, if I remember correctly, is the healthy output, and the other one's a speed or a start-stop kind of indication. But they can be programmed and customized, this group down at the bottom here. Now, the ones we're going to be focusing on primarily are these first groups that are wired to my DW240 over here. So we're going to, there's a 24-volt supply built into the drive so that you can backfeed this if you don't have three-phase power, and the drive display will actually power up. And then when you apply the power, it'll go out of external 24-volt mode on the display. And depending on the state of the drive, it'll indicate inhibit like it does here, or whatever the state of the drive is, whether it's running, what current's being pulled, those kind of indications. Generally, terminal 2 is the start signal. Out of the box, terminal 3, digital input 2, is a reversing function. Digital input 3 switches between the analog reference that's coming in on terminal 6, and depending on the state of that, it'll actually go to preset speeds based on terminal 10, 2 preset speeds that you can adjust. The STO function at the end here, that's when you're inhibited like you are over here. That means my STO is actually turned on, meaning safe torque off, so it inhibits the output stage from firing the IGBTs. So there'll be no current going out to the motor when that opens up. It just quenches the drive's output. Now we've got other controls we can signal. What we're going to do is go through the basic setup of these controls out of the box. I've got let me erase my yellow here, and then we'll go back in pointer mode. I'm going to open up everybody, just see if there's any questions about the terminals before we move on. Give me 1 second. Anybody have any questions about the layout of the terminals or what they do? We'll get into it deeply as we go on. Okay, I'm going to leave that open unless we get some background noise so that anybody can raise their hand electronically. All right, so first thing we're going to need to do before we go into commissioning mode and wire the drive up, we're going to need the motor nameplate data. Now these motors, this is a nameplate right off of this motor that's down here in the lower left-hand corner. And we've got it on a 460-volt wiring configuration. We've got this is the speed 1735 off of based on the slip of the motor. It's 0.8. It's just a 1 horsepower motor. Full load amps, it's just a 0.8 amps. And really, that's all we need off the nameplate to get the motor turning. Okay, so I'm gonna shrink that down and put it down below here. And then we're gonna go into our left-hand drive that you see here. And I'm gonna open up another window in Savvy. And I've got a control window where I can turn these inputs on and off. Oops. Imported the wrong program. Let me import it real quick. Excuse me 1 second. Okay, this is my control scheme here. Okay, and let me just open this up a little bit. Now, when you first go in with the Speedy plugged in, now you see this little yellow triangle that's showing up over right here. That indicates that the drive is out of the box at its default configuration. I haven't put it into drive web mode. Now, we'll talk about that at the very end, about what that does. It sets the drive up so that we can take complete control with our Speedy or our Smarty, if it's plugged in, of the block diagram. Now, we're going to actually just commission a standard drive, and then we'll get to that later in the presentation. Okay. So the first thing, we got the nameplate data. We have a little parameter down, let me just zoom in there so you can see it. You see this drive setup window? This is made to commission through all three steps all in one location. Okay? And for the motor nameplate data, this will get you straight to the basic motor setup. Now you could go to the parameters as they show up in the manual, but we're just going to exploit these features and go in and set the motor nameplate data. Now I'm going to set these back to the defaults. I was making sure my rig worked before. And then this is what your motor looks like the motor setup right out of the box. Okay. So if we look at the little diagram we have back here for the drive. Now this is basic in volts per hertz mode in all modes. You really need to get this information in there. Now the drive will default to the right 460 or 230 volts or 600 volts if it happens to be that size drive. But the information for the current's going to vary based on how big the properties of your motor. So I'll put the 0.8 amps in for the motor rated current.
How would you notate that?
Let's zoom in so you can see that a little bigger. The power factor we really don't need yet, but I'll show you that in a minute. That's usually used when you go into open or closed loop vector mode. It gives you a better auto-tune of the actual properties of the motor. And then the rated speed was 1735 at 60 hertz. So we'll put that in so that the slip compensation works in the volts per hertz mode. So it compensates based on entering that information. It compensates for the slip of the motor and gets you better starting performance. Okay? So we'll just leave that at that particular. That's all you really need to do to run in volts per hertz mode. Okay? So if we're going to go over here, let me just make this a little smaller. We're just going to be working on the left drive you see here. So you see it's in inhibit mode right now. I've set the motor nameplate data per the nameplate. Now you see the safe torque off. If I turn this on, you see that drive went from inhibit to stop mode. Can you see that? I'll make it a little bigger. So that's the safe torque off. If you see inhibit on the front panel, that means that it's been inhibited from producing current. We'll enable the drive and it's ready to run now. Now terminal 2 will actually put it into a start state. And let me just get my highlighter out. I'll show you. That's going to be right about there. That's terminal 2. And then when we start it, you'll see it'll go from stop to start, and it's sitting at 0 hertz because I have no reference on terminal 6 yet. Now all I've got to do in the savvy world, this would be equivalent to just turning your pot up. We'll just bump it up a little bit, get the motor turning as you see there. Check the motor rotation, make sure it's rotating correct direction. You have two options. You can change the direction in the software. It's in the P4 menu, which is what this little guy is here. These are all the different menu groups when you're in Savvy. That's what the little display looks like. And you see there's a parameter that you can change to change the direction of rotation without swapping the wires. Generally, I like to do it on the terminals, but that'll expedite it. If you want to change the rotation, it'll actually give you two options to change the rotation direction. Okay. So we're running along. We're happy with this. Let's go ahead and take it up to full speed. Now this is just turning my pod up, and we'll just ramp it up to the 5-second ramps of the default ramp rates. Okay, and they're all in this drive setup page. You see you got the ramp rates right over here. You see they give you the parameter numbers if you want to set them through the front of the screen. I'll just zoom in on them. It'll be a little cleaner. So there's your ramp times, P103, P104. Okay. Let's say we make the we'll make it slow, ramp a little slower down. We just change the ramp rate.
I'm just in the middle of getting your quote together.
Then as we just bring it back down, let's just set it back to 0. It'll ramp down to 0 on the 10-second ramp. Now that's 10 second to base speed. So that's if you wanted to go above base speed and you set the max the max speed at, say, instead of 60 hertz, 120 for the max, it would field weaken as you go above 60 hertz. You know, you lose some torque, but you get more speed out of the motor. You just change the upper limit. You don't reset any of the motor nameplate data. You just set the max speed up to a higher value. Now, one thing I wanted to highlight while we're in this mode, let me just set this back to the default, is when you're, whoops, I was actually in speed mode that time. I meant to be in volts per hertz.
Can I just do the trapezoidal move using the
So let's go back to
I don't think so. You really
stop,
gotta have the,
start.
you're gonna need a smart. Yeah. So he's gonna need to take
Drive will work the same, of course, because it's
He's not that familiar with the trapezoidal move.
set up for volts per hertz.
He's got
So
the
now,
motor on the motor. Is he gonna have
let's
to
go back in speed here. Let's go back down to 0.
Smarty as well?
One thing I wanted to show you that's a little different, if you go into the, let's go down into start-stop control down here. Now you can't see it, but there's in these smaller drives, you can put a brake resistor built into the drive itself. It slides into the heatsink, and it terminates to the wires, 2 terminals down at the bottom here. It's this red wire you see that's sort of under the drive. Now, you see this says the stop mode is a little different in that you've got certain modes of operation where it says no brake. That means don't turn on the brake transistor. You see where it says ramp to stop, no brake, coast to stop, no brake. Those first 2 items, and if you do a get info on the parameter in Savvy, it gives you a description right out of the product manual. So these first 2, ramp to stop and coast to stop, just say, hey, the brake transistor doesn't exist or I don't want to turn it on. Now, if you do fit a resistor, you got the same 2 options, but that turns on the braking transistor. Ramp to stop with brake, coast to stop with brake. Okay? So we're going to turn that on since I do have a resistor, and I'm just going to do a ramp to stop with brake.
I've already been down that road. Thank you.
Now, Savvy will show you that's not the default setting. That's what that little brown bar at the bottom means. But I just turned on the brakes so that if we want to do fast stopping, we can do that. The brake transistor will kick in. So we run it back up in speed. And let's say we do some crap. Hopefully I don't trip the drive out, but let's set it for a 1 second decel. Okay. And then when we turn it off, it's coming down much faster within the rating of the brake. Or the resistor, I'm sorry, the transistor itself. So we're running in volts per hertz mode, pretty much happy with everything we did. It didn't take too long. The only thing I will say in volts per hertz mode is the default. Let me just zoom in here. Let's go back to the setup screen. Where all the parameters actually are. If you look at the ramp to stop, see that this is just another image of the actual parameters. The thing that you may get into is that when you're in volts per hertz mode, you can actually tell it to how much boost you want to give the drive. You see down here in the V per F setup. The only thing you may notice in the US is that the default numbers, if you start seeing on the display, their little dots will show up on this display if you see flashing dots on the display, it may at 0 speed, at real low speed, it may be that your boost is set too high. So it's overfluxing the motor and pulling more current than it needs to. In some motors in the US, I've had good luck with, if you start seeing those dots on the display showing saying it's overloaded, it very well could be the boost is too high. You cut it in half about, and it'll settle out to get out of the region where you're overfluxing the motor. Now, of course, we can't change the modes of operation while it's actually running. But we're going to go ahead and stop it, and then we'll go to the open loop vector mode. I'm going to open up the mute to see if anybody has any question on volts per hertz mode. Anybody have any questions so far? Okay. I'll leave the mic open while we move in. Now we're going to go in. I'm going to reset these to factory defaults. Okay. Oh, I can't change that particular parameter. So let's go. We're going to actually change the mode of operation from volts per hertz to open loop vector by just toggling this mode at the top here to vector speed mode. You have a vector speed and a vector torque, depending on your application, whether you want to speed limit or torque limit the drive. We're going to do vector speed for now. Now the power factor may or may not be on the motor. Some motors it's actually on the nameplate. Other motors, this marathon motor, if you look at that nameplate, it doesn't tell you the power factor. There's nowhere that I see it on the nameplate. Now I happen to have the data sheet for this motor, and it's something that's published in general. If you don't have it, use the power factor that's in the drive, because the default setup is based on how big your drive is. It may be fine, but you ideally, to get the best performance, you want to get that power factor. And if you look on this data sheet, it'll be what's the value at full load, the full load power factor at 7.2. You see that? So we're going to put that in before we do the Autotune. Now this isn't a rotating Autotune. It just pumps current through the motor. And you'll see when we go into Autotune mode, you see how it's in a stop mode right now. We don't need to start it or the like. As soon as we hit this button that says Autotune, you'll see ATU will display on the front of the drive. Okay? Well, that's the wrong drive. That's the right drive. You got to stay on the right drive, of course. Vector speed. Let me make sure these are reset. You'll see these are the Autotune parameters after the Autotune. I'm just putting these back to like it's right out of the box. Excuse me for 1 second. Okay, so that's how the drive ships in the big scheme of things. Go back in here. We're gonna reset no PPR yet. We're not gonna close the loop on it. We're gonna just run it in open loop mode. Everything else should be okay. So we'll put the power factor, what was it, 0.72? Yep. Okay, and then we're going to enable the Autotune. Okay. Now you see on the front display it says Auto T for auto tuning, and it can take a while for that. You don't really have any indication on it's not something that's available through the Speedy connection, but the display will tell you when it's done. It's pumping current to the motor, and when it finishes, you'll see these values change in the actual setup of the drive. See, it just finished. So those are the parameters it's looking at. It's looking at the motor stator resistance, the rotor resistance, the stator inductance, the magnetizing current, the leakage coefficient, all these normal things that create a good motor model for you to run an open loop vector. So now we've done our Autotune. These are off of the default settings, so we completed it successfully. There are errors that you can get in Autotune. It'll tell you what to do pretty much. Like if you're in encoder mode and you're trying to actually Autotune and you don't set the PPR of the encoder, it'll squawk at you. And different faults that are in the back of the product manual. Now I have a full copy of the manual here under manuals. This is up at the website, the P2 series, the entire product manual. And on the very back of it, you'll see all the different troubleshooting tips. Okay, I'll just leave that, minimize that for now. Okay, so let's go ahead and run an open loop vector. And let's see what we can do at the low end. We'll just reset the speed to the default. We'll start the drive. And let's just get, you see it's, you don't have the loop closed yet, so you can bump the speed up in little steps. But because we don't have an indication of actual speed of the rotor, we have to get up to about, I don't know, about 3 hertz to get the thing rotating, because it doesn't have an indication of what its speed is, what it needs to do. Once you get above this low frequency value, it varies based on the motor and the drive combination, but once you get above this threshold, it performs really just the same as the closed loop vector, but you'll see when we close the loop how we can crawl at a much slower speed. So we can take this up, run it up in open loop vector mode. Now we're running full speed here. Just let it stop again like normal. So once you've got the Autotune done, that's pretty much the vector setup for the open loop mode. So that's the second of the three in 3 modes. We've already done volts per hertz. We've already done open loop vector. So now we're going to close the loop. There's an encoder on the back of this motor that we can use. And there's actually another, I'll just show you what it looks like. In order to close the loop on the drive, there's this encoder option card. Now this slides right into the lower left-hand corner of the drive. There's a socket that can be used for things like the encoder interface module. It just slides up into there, and it's for line driver type encoder signals. So you'll have an A and a B channel. If you look at this data sheet, you have an A and a B and their complements. You have a 5-volt supply if you want to use the internal supply. You can also wire with another module. If you have a higher voltage encoder, you can do a 24 volt, but you have to supply that 24 volt externally. Okay? This comes with the encoder option, where it slides in and how you commission it. We're going to go through that right now. Now you can actually run the drive in this mode of operation without turning on the encoder to make sure your encoder is working, so it doesn't get confused. So I'm going to go back to our setup screen. Make this pretty large here. Now you see this thing that says encoder speed, P058? Although it indicates in hertz, it'll tell us whether the sign is right on the encoder. That's the most important part of it. And it's mentioned in that application note for installing the option. So I'm going to go back. So what we want to do, if we got the A leads B or the B leads A correct, for a positive reference, this should be positive. Okay? Now the two things we have to set up is the encoder PPR that you see over here. That has to be for your encoder. In my case, I got a 1024 encoder. Okay? And you have to have the rotor speed at 90. So I'm going to put it at 0, and let's just pretend we're going to start it. Okay? You'll see. It may have already faulted. Let's see. So if you don't set the PPR, it's going to say you're not really ready to go in that mode. Okay? You see it says encoder 3. And if you look at the fault code, that effectively says you haven't set any RPM for that thing. Okay? So what I'm going to do is set that back up to 1735, even though it'll be synchronous speed now because it's an encoder. Okay. Now we're running in open loop vector mode, but you see our encoder is generating a positive signal there. We're going up to full speed. That's our encoder effectively. Okay. Since that sign matches my positive sign for the reference up here, I can go ahead and enable over here the encoder feedback. Now I can't do it while it's running, but I'll stop it. And then once it's finished running, ramping down to 0 will enable it once it stops. Okay, we stopped again. So let's re-enable. Let's enable encoder feedback. And I'm going to put, let's see how small a number we can get in here. 0.1. Let's just do 0.1. Okay. And so we're going to start it in encoder mode. Now you see nice and smooth, slow speed operation. That's about 0.4. Now, through our drive web technology, we can get higher resolution on this if you got more demanding applications. This is just an analog input to the drive terminal. But that function block that we're going to talk about in a few minutes, this control block sets it up for drive web mode, which gives a 16-bit resolution on this speed reference. But you can see it smoothed right out to a nice, stable, slow speed. And then we can just let it ramp up accordingly. Now the other parts of the drive setup screen you see back here, once you've closed the loop in open loop or closed loop, you can set the P and I terms here to tune the drive up. Here's the proportional gain, P403. Here's the speed, the integral gain, or time. Normally, I've been pretty happy with, at least to get started, once you've got it in open loop or closed loop mode, especially closed loop mode, you can double this proportional term to get the drive to really perform like a servo. And then you may take this time constant for the integral term down to 0.01, much shorter integrator. And you can really get this thing to move through its steps if you're doing a motion control or something along those lines very well. So now we've closed the loop and we're ready to apply the, whatever logic we need to get the drive to operate. Now, I did say at the beginning that we were using the default out-of-the-box setup. Let me just show you something about the manual real quick, what that means. If you're not customizing the drives block diagram using drive web, what you can do is you can go into the drive setup screens. These are out of the product, just a few pages out of the manual. And let's just zoom in here for a second.
Because he did say he would take, because I said to him at the time, I said, well, I might have to shift to one. And
So if you look here where it says P112, the P112 and the P13 parameter, which you see on the next page, these two parameters set up the modes of operation. So I've been working in terminal control, which is the mode out of the box. And your main speed reference is the analog input. So we're using the default for what the mode of operation is. You can switch it into keypad mode, PID control. And when we go into the drive web world, we're actually using this can open mode. That's how we talk to the drive, through can open. Now, if you're in terminal control mode, this tells you what out of the box, P113 is equal to 1. These are what the terminals do. And if you look at what our picture in our drive web world is, this is what even though we're not using our program, that's the drawing of what this mode of operation is. So you see digital input 1, terminal 2 runs and stops the drive. Digital input 2, terminal 3 goes forward and reverse. Let's just do that. I don't know if we did that yet. So it's going at full speed, one direction at 60 hertz. Let me bring my control back to the front. We'll turn on the reverse mode. And now you see that just turned on terminal 3 so that it goes through 0 and reverses, goes back and reverses at whatever speed we add. So that's just like we're doing exactly what it shows here. And so if you look as you go left to right, so we go forward and reverse. Let's take it back into forward mode. Okay. Let me get this down a little lower. Now the next couple of inputs, if you see as you look through this manual, so if we turn on digital input 3, terminal number 4, we'll switch from the analog input 1, which is this reference here, to preset speeds, which are a function of this last item over here. And if you look, you see you got 2 presets in the drive. We went to the first preset because we hadn't turned it on yet, which is by default 5% or 5 hertz. If we turn on this next input, we'll go to 10 hertz, which is the second preset. So you can control the behavior without a Speedy board fitted to the drive through all these different choices of the modes of operation. You can have up to 8 presets based on, if you were to set P13 equal to 12, this is how the digital inputs operate. Okay? And so we can go back into normal run mode. You'll see it'll ramp up, and then we'll stop the drive. So that's the commissioning part of all this, okay? So you can actually you've gone through the commissioning of the drive from start to finish, assuming you get your wires all in the right place and all the basics. Anybody have any questions about this before we move on? Now, the beauty of the Speedy here is that I haven't done anything in the drive that isn't native to the drive. We talk about this in the drive web class, but there's a little divider here. You see this little divider in our picture? Anything below this divider is built into the drive. These are the features that are built into the drive. Here you see the slightly less green colors. These are the actual physical inputs that are in the drive. These are the physical outputs. And these are all the parameters. They're always in the drive. Now, we put a few things in there to do this drawing, but I can throw these away right now and not affect the performance because with that triangle there, it's telling me I'm not running in drive web mode.
Yeah, and
So all these are is for representation purposes, these blocks here. Okay? Does that make sense? Until we hit this button, this little triangle, and put the drive in a full drive web mode, we're just using the default block diagram. So as a user, I can come out and unplug this Speedy, and the drive will behave just like everything we've done so far without any customization. Okay? So this is where you can use a Speedy to walk around. Say you got 20 drives in a cabinet. You can have one Speedy if you're not going to use the Ethernet and the capability of the peer-and-peer communication and the expansion of the block diagram. One Speedy will allow you to back up all those drives and talk to them either via Ethernet or micro USB to do your commissioning part. Because there's different protocols on this port that can do other things, but we only use. Somebody says, do you need to save the program? No, the program is actually, when you power down the drive, that's when the drive saves it. So you don't have to do an explicit save in the front panel. That's a good question. So the drive powering down will automatically save it. Now, in my case, I might want to save a copy. I'm just going to throw these away to show you what it looks like. Let me just throw these away. So I can lasso these guys. Since they really aren't part of the program, I'll just throw them away. You see how they go out of the top list. They don't really do anything. Let me throw this one away. And now if I were to back this drive up, if I back this drive up right now, this is how it would be if you don't use our program. And now if I just right click on it and export the text file, I'll just say all parameters. Let me put it on my desktop, and this will be all parameters left. And we'll just put it on our desktop. So what it's doing is it's talking to that drive from my computer through the Speedy. And if we go over and look at the file, even though the drive will save them, here's a copy of all the export of all the parameters out of the drive so that I have a hard copy of what was changed. So there's all the drive parameters. That's another benefit of the Speedy. You can easily get those parameters out as a backup copy of what's going on in there. Now you don't have to leave the Speedy. It's just using the Speedy to get all those parameters out of the drive. Now the ones you see that have the little hashtag in front of them, those are the ones that are not at the default. So those are ones we changed in the commissioning. Now some of them are diagnostics, like how long has the drive been running. Some of these P0 parameters that you see in this group, those are just they're totalizers that keep track of how much you've run the drive, how many hours, how many seconds. Since this is in our training room, we already got 200 hours on it. So this you can get out of the drives via the Speedy. And now you got a hard copy of that particular drive setup. Now if you put the Speedy, if you also can save, if we do another export, we can save the program. So we go, that's the left program, I'll call it. And I'll save that to my desktop. Now that program is something I can load through the Speedy to set the drive up. So say you're doing cookie cutter drives, you can actually set the same program in every one of them. Now the last part I wanted to go over before we got a few more minutes before we wrap this up is how do you set it up for drive web? Now we made it so you only hit this little triangle you see here, okay? But if you go into, let's go into the parameter group 9, we can see how these all have not default settings. This is how the drive out of the box is set up. When we hit that little triangle, these will all be set up so that we take complete control of the drive's block diagram. All those different selections for P12 and P13 and everything, they're insignificant once we hit that triangle. Okay? So if we go back to here and we hit that triangle, so I went inside and it's saying the drive is not currently set up correctly for drive web. Would you like to do it? If I say proceed, don't change any of these other settings, just hit the OK button. The triangle goes away, and if we go look at the P9 menu, everything's says it's at the default for drive web. So all those, this is all the setup that puts it in our control block mode and the drive web mode. Now we can customize the block diagram all we want. Okay? What you see here, this control block is something we built to give more power to our drive via the Speedy. Once you go into the drive web world, you got to leave the drive web device there in order to do the application. So say you want to make a connection from one drive to another, you can actually do that across drive web. So this is our left drive. Let's look at our right drive. And I'm going to set this one up for drive web mode 2. Okay? Okay? Now, the thing is, so what we're going to do, the terminal still is controlling the start of the drive. You see here, maintain start. But let's say we want to take the left drive speed reference. We'll take these away. We're not going to use these terminals right now. And I'm going to do another viewer and open up my other drive. The one we've been using so far. And if you look down here, we have a speed set point we can put in. Our torque set point's there. So there's our speed set point. So what I'm going to do is I'm going to make this go over. I'm going to start a connection here. And I'm going to make it connect up over to here. Okay? And it tells you where it comes from. It comes from the left drive. So both these drives should have the same speed reference. I'm in complete drive web mode. They both have speedies on them, and they're talking to each other. So let's go back into the control mode. This doesn't do anything right now. I'm just going to put it back down. So let's turn the torque off, on. So we should be at a stop state. Let me change the size of this a little bit. So there's our drives that are talking to each other directly. Let's start the left drive. It'll sit there and actually run at some speed. That's the right drive. So the left drive is running at speed. Now I got to figure out why my right drive's not running. So that's our left drive ramping down. Torque limit set up fine. It started. Where's my signal coming from?
That one that's just a bare resistor sitting there?
There we go. So we're both running, one's following the other across the network. That's how you can do your system type level processing. If each device has a drive web device plugged into it, whether it's a Smarty or a Speedy, they can talk peer to peer to each other, and you can control them. You can actually start them via the network and everything. I just left it for an example using the terminals that are built into the drive, using an external device. I'm going to open the floor up to questions. We got about 5 or 6 minutes left. Let me turn everybody's mics back on. Okay, does anybody have any questions about what we've seen today? Anybody have any questions?
I have a question.
Sure. Who's this?
I'm Tom with the of Dynatech.
Okay.
So we have a P2AC drive that connected to the DW214 Smarty.
Uh-huh.
Now, I saw that you mentioned about the encoder optional terminal. Is that required to run, or can we wire can we wire the encoder into the Smarty, or do we need the optional encoder terminal block?
Well, you can wire into the Smarty, but that's not going to close the loop on the drive. The drive has its own encoder input. So you can use it for, say you wanted to follow an encoder for a reference, you could wire that into the Smarty, and then that could be the speed reference to the drive in open loop mode, let's say. But it needs to have its own feedback. What carrier do you have? How big? Do you have a 3 or a 4? Is it the widest one?
No, wait, which one would that be? I have no idea. I don't know.
I'll show you the difference real quick.
Okay.
So it's on our home page here. So these cassettes that you see on these units are all the same. This cassette, and it depends on which. These are called carriers. What you plug into them, into. So this is carrier 1. This is carrier 2, 3, and 4. Now the 4 has the 3 will take an encoder in, but it doesn't have a retransmit built into it. The 4 has 2 encoder inputs and 2 retransmits. So you can take your drive inputs into here and then feed them back to the drive through the retransmit so you can close the loop. But you still have to have that module inserted into the drive to get the best, like if you're doing electronic line shafting between drives or the like, usually you would be using this unit. Now you can parallel up if you've got one of these. You can feed your Smarty in the daisy chain. They don't draw much volts, or current, I should say, to those. Those are high impedance inputs to the encoder card. So you could bring your encoder and power it from the Smarty, and then daisy chain it over to the right terminals on the encoder module, and just tie the commons together, and be fine in the big scheme of things.
Okay. All right. That sounds like. So it depends on the carrier that we have currently on our drive.
Well, only the 3 and the 4 have encoder inputs. Okay. The other 2, this is like our existing Smarty, the second generation, the 210 you may have seen. That has just analog. That's what I'm using in my picture back here. Is a let me erase that mess. That's what this is, a carrier 2 that's plugged in just to control the I/O. That's a second carrier hooked up. Now, I got enough room to put a 4 and a 3 in there, but I only wanted to control the digital terminals here. Has anybody started up their own P2? Did they learn anything out of this session that they didn't know about P2s? Is there any applications coming up? You may have a question.
Hey, Tom, this is Rick.
Yeah.
I do have a question. Actually, sends back to the first part of your discussion, but just
Okay.
wanted to make sure I understood okay. You said you could program the drive or power up the drive by connecting 24 volts, if I
Yeah.
understood right,
Right.
to terminal, I guess, 1 and 7.
Yeah, let me
You can
fire.
do all the programming with just that without having the drive actually hooked up to 480 at all?
Well, you can do it in phantoms, of course, the offline files, but in order there's a let me just explain. So the drives, each of the drives have two processors. One is the control board that is common to all the drives, but the power base has its own for the size of the drive, like say it's 100 horsepower, there's a special power board for that product range. That has a processor on it also. So you can do the programming and the like, but if you're going to load like the motor information and the current limits and all that, you can work on it offline with the Phantom, but you need to turn on the 3-phase so that other micro's turned on when you get into the mode where you're actually putting your drive parameters in. Does that make sense? There's a boundary between the top control board, by being externally powering that 24 volts, it allows you to keep your network up and the drives talking to each other if you need to pass a signal. But if somebody isolates the 480, that turns off the power section. So that you can turn off the power to a drive, but you can still keep the peer-to-peer communications up.
Okay, that makes sense.
Yeah, and it's let me just show you something out of the manual, which is pretty handy when you're new to the product, especially. Let me see if I can find it here real quick. It's the pictures of the different keypads, but one of them, when you see ETL24 on the front panel, that means it's powered from an external 24 volt supply. There's some pictures in here somewhere. So we do that in our systems and the like so that, the brains of all of them will be up regardless of whether somebody turns the power off to one drive or another. Here we go. I'm getting close here. You see right here?
Okay, yep.
Yeah. So that's what you'll see in the front panel. Now we have two different screens for the bigger drives have an OLED screen, which is more like this with the text and everything. The segmented display are in the little drives that don't have the high-tech display on them. But the bigger drives, it depends on the frame size. You'll have, both of them will display the same information, but you won't see P101. You'll see the name of the parameter and the like. But these are a lot more, the bigger drives they'll tell you different things while you're on a certain screen. And I think they're going to work it in through the entire product line at some point.
Okay. Thank you.
Mm-hmm. Does anybody else have any questions?
That was really good, Tom.
Thank you. If anybody has any questions, I live at my desk. Feel free to give me a call to follow up or anything. And hopefully this gets you through the learning curve with the product, at least get the motor turning. But then if you decide to go and add your Speedy and actually do a system with DriveWeb, that's something we're going to, we already have the basic course, but we're going to try to do more with maybe next month we may do Savvy Panel, how to use Savvy Panel in the DriveWeb world, or something else. We'll see what the demand is for. So we're going to try to do this once a month. You'll see the newsletters when something's scheduled. Well, thank you for taking the time to come, and hopefully you'll all buy some P2 drives now. All right, thank you. Take care.